Good afternoon, everyone. Thank you for coming for this Building Science Graduate Program information session. We do this once a year to give more detailed information about our program. And if you have any questions, we'll be happy to answer and tell you all about the nice thing about our program. My name is Fusum Tariku. I'm the director of the Building Science Graduate Program. And today we have faculties Bo Lee. He's the program coordinator of the master's degree program, and Rodrigo Mora. He's a program here for graduate certificate in building energy modeling. And Maureen currently, unfortunately, she will not be here. She's not feeling well, so Ahmad will be speaking on her behalf. So Ahmad is a research analyst in her program. And of course, Ellen Skawi, our program assistant. I'm sure you will interact with her more. And Ali, master's candidate, he will be finishing his master's degree maybe in a month's time. And he's also the building science student club coordinator. What do you call it? Coordinator. Okay. Okay. So our today agenda we'll be talking about the program highlights, and then we'll tell you the research infrastructure that we have in our program, and then the Center for Architectural Ecology. That's Maureen. We'll be talking about that, and the new program that we started about a couple of years ago, on graduate certificate in energy modeling. Rodrigo will be talking about that, and then we'll tell you just a little about what kind of research we do as a faculty. And each of us will have just a few minutes, and if you have more if you would like to get more information, you can ask us later, or you can make an appointment by email, and then we will be happy to talk to you more in detail. And Ali will be talking about the student club from his experience, and Ellen will be talking about the admission, the requirements, and the procedures, and then we will answer questions if you have any questions. But this time, if you have any questions, feel free to ask, and we'll answer it as we go. Okay. So the program, the Building Science Graduate Program, started in 2011. That's about 7 years. And we have been taking about 15 to 18 students every year. And these students are mostly from master of from engineering background and science and architectural background as well. The program is we call it one of its kind in Western Canada, because building science, as you might know, it's kind of a specialized field. It's not from mechanical, it's not from civil, it's not from architectural program. This is a combination of from different disciplines. So our program takes into account, or takes in connection of all these disciplines and put it together and then create this program. So there is no program that has a similar kind of courses or research activities and provides a credential at the master's level. So this is a different kind of program in Western Canada. And this program is also actually initiated from the industry drive. So just to give you another background, in the 1990s, there were leaky condo crisis, and the industry put together, and they want to have a program, actually research activity and education in the building science area. That's what motivated BCIT to develop this program. So we are backed by industry, and we closely work to address the industry needs. This graduate program actually started from the Building Science Center of Excellence. It has three main activities: applied research, doing a field experimental study, or field monitoring, computer modeling, basically to address industry needs, industry solicited kind of project, and also research project funded by other parties. And then we had also an educational support in the diploma and degree programs. And now we have this master's degree program, which will supplement the whole activity. So this program is an engineering program. So it looks at problem solving from the engineering point of view, and we focus on applied research and providing industry solutions. So you usually ask industry, what's your problem? And then we will bring that as our research project. It could be in a Master of Engineering or Master of Applied Science. So it's highly motivated by industry solution kind of projects or activity that we do. And our course is also developed to address those kind of needs, industry needs. And we believe we have a strong foundation of research infrastructure in all areas, so that the students will have an opportunity not only from education, also from research activities. Our funding partners, we have grants or support from INSERC, National Science and Engineering Research Council, from Canada Research Chair, Canada Foundation for Innovations, and the provincial government like from BC Housing and also CMHC in the past. And one thing that I wanted to bring to your attention is the INSERC. INSERC provides funding to researchers, and also they have a funding mechanism for students. So if you are interested to come to our program, master's program, you can apply to INSERC, and you will have the opportunity to secure some funding, and then basically you can support your research or your educational program. So we highly encourage you to consider that. In our program, we have basically 3 credentials: Master of Engineering in Building Science, Master of Applied Science in Building Engineering / Building Science, and also graduate certificate in Building Energy Modeling. So 3 credentials. So what's the difference? The MSc is it's coursework plus a research, and for the Master of Engineering, it will be more courses plus a research project. But the research project, we call it a comprehensive research project, meaning it will be about 2 term project. So it gives a good opportunity for students to solve some industry problems or to do some kind of advanced research, even the MH program. But for the MSc, it's purely research-based and highly detailed or the in-depth research is required. The Master of Applied Science program, it's a 2 years program. So as I said, it's less work, more research. For the Master of Engineering, it's a 16 months full-time course. Program is more course, and again there is a research project or industry research project. And MSc about 36 credits and 33 credits for the Master of Engineering. All these programs could be taken as a part-time or a full-time program. And as of now, most of our courses actually start in the afternoon, after 2:30, so that it will allow industry practitioners to attend our program. Currently, we have 43 students, 14 MSc, and actually 18 MSc, 14 full-time and 4 part-time, and about 24 Master of Engineering and graduate certificates, 1 student. And the picture that shows is in one of the class, which is a building envelope course, in a collaborative way of learning, and we encourage that kind of learning. In the past, this is where our students, their backgrounds: civil engineering, about 36%, mechanical, 26%, electrical, material integrated, and others means architectural programs and science programs. Architecture is 9%, so the other is more of science, it's from science programs. Our students come from different countries. We have about 18 countries from all over the world, and so far we have 54 graduates from 18 countries. 22% of them are female and 78% male. In 1 year, we had actually 50-50 students, 50% female, 50% male. We have 43 Master of Engineering students have graduated, and I would say all of them, or I think most of them, will get a job just after they finish the program. 9 Master of Applied Science have finished, and 2 graduate certificates in Building and Engineering Modeling have finished. And this is where our grad students go, mostly to consulting and engineering firms and architectural firms, and some go to research, and some also go to do their PhD and other universities. So that's where they are, and now just on a highlight, and then Bo will be talking about more on the research infrastructure. As I mentioned, our program is unique in terms of the course structure that we developed, integrating different disciplines. And our education and research focus on mainly on those 4 activities. One is building envelope design and energy modeling, mechanical systems and control, indoor environment, and acoustics. So and the students will have the opportunity to take all courses in all these areas. So when they come out, they will have good information or good knowledge in these areas. And that's our focus in both our education and research. Okay, now I'll leave it to Bo.
Thank you, Faisal. Okay, and I can give you a brief introduction about our program's research infrastructure or facilities. So BCIT Building Science Graduate Program has many advanced facilities and equipment that enable experiments under controlled environment conditions, as well as those experiments under real outdoor conditions. So our field monitoring equipment can also be deployed to evaluate the in-service conditions of buildings. So experiments and field data feed out advanced computer models to accurate, which is able to accurately simulate building performance at the materials, components, systems, and even the whole building systems level. So those research facilities include hydrothermal property measurement lab, which is this one, and also building envelope test facility, which is this guy, and the whole building performance research lab, this one. I give a brief introduction for those research facilities one by one. Okay, good. So this is the hydrothermal property measurement lab. This lab is equipped with test apparatus to measure hydrothermal properties of most commonly used building construction materials, including the vapor permeability, isothermal sorption, water uptake, and the thermal conductivities. I have another one. Then this is the building envelope tester facility. This facility is the only known 2-story research facility of its kind in West Coast rainforest environment. So this lab is created to evaluate the hydrothermal performance of full-scale building envelope assemblies and the associated products under simulated indoor and outdoor conditions. So a broad range of the building envelope as well assemblies at various sizes can be tested in this lab. So this facility is equipped with a data acquisition system having more than 600 channels, allowing for the monitoring of hydrothermal conditions within wall assemblies, including temperatures, relative humidities, moisture content, heat flux, and air velocity, wind-induced pressure, and the instance of condensations and also the rain penetration. This next one, this one. If you look at that, those are the whole building performance research lab. And this is the whole building. This lab is used to conduct a research on the dynamic interaction between the building envelope components, the indoor environment, and also the mechanical systems. You can see here is that there are 2 identical 250 square footage buildings which are fully exposed to the natural outdoor conditions here. One of the buildings is used as a reference, and the other is used as the testing building, so that we can test a particular mechanical system or envelope systems. I mean the design options, so can make comparison in between. Each building's envelope include the walls and roofs are removable and is fully configurable to allow testing of various building envelope systems or materials. Each building here is equipped with separate mechanical systems for heating, cooling, ventilation, humidification, and dehumidification. So they're able to do that. And this lab is used to evaluate various building design options, as what I mentioned, in a holistic way, with the objectives of choosing design parameters that actually can lead to a reduction in energy consumption while maintaining a relatively satisfied indoor environment. Except for those research infrastructural facilities, we also provide some advanced software and also computer simulation tools to be used. As what we mentioned, that the site field or monitor data can be fed into our advanced computer modeling systems, and most of those modeling systems are established by using the software listed here. So this is a console, very good, strong in the CFD simulation. Transys, which is developed by the Wisconsin University, the Solar Lab, and it's very, very commonly used software for building energy performance simulation, or even the solar system, domestic hot water or PV systems. Design Builder probably is, I don't know any people is familiar with that. It is Energy Plus based engine software, which is widely used in industry and even in university. People use that to simulate the building performance, to conduct a kind of research of the building performance analysis. MATLAB Simulink, which is sometimes most of the software, for example, console Transys might have some built-in module which enables the user to model a particular systems. However, some of systems maybe are very innovative, and it end up to be that non-existing software can be used to explicitly simulate this kind of like mechanical systems or building systems. So you have to use some kind of MATLAB Simulink to write some code and to help you to finish your research and simulation. And some other open source simulation tools like eQuest, stuff like that, and we all use that. And this one is we mentioned that it is some of climate chamber, weather chamber. So this or environment chamber, and this environment chamber is as shown here is a multi-purpose test facility, which is usually we use to evaluate the performance of a full-scale building envelope systems under a controlled environments. So you can see it as a cold box and a hot box. We can simulate the different indoor and outdoor conditions for a particular test specimen in between. Okay. And I will pass this to the to Ahmed. Ahmed is going to give a brief introduction about the green wall and green roof systems.
Hi everyone, my name is Omid Tamana. I'm working with Dr. Connelly on the Center for Architectural Ecology. Unfortunately, she couldn't make it and asked me to come here for some information about this project we done in this center or we are currently busy. Center for Architectural Ecology actually consists of a couple of labs. It's started with working on green roofs and living walls first, and then project related to acoustic for the living walls and the green roofs. And now we are more focused on the acoustical or architectural acoustics, because the city growing and more population in the city getting dense, and sound and noise problem is getting more and more issue actually for the consulting engineers and architects. So we are working mostly on the acoustical projects right now. The picture you can see here actually it's a picture of the living architectural lab here. The other one is the facility for the transmission loss. And this one it's a small one, is kind of scale 1 to 10 anechoic chamber, which we can put the samples of the buildings scale to 1 to 10 and then do lots of tests on acoustical test and measure on this. We have a couple of facilities around BCIT and outside BCIT actually for our programs. One of them is the the elevated lab is in the other building, actually on top of the carpentry shop, which we have green roofs on it. And we had a couple of projects on that green roofs. And one of them, which is currently we're working on, is I think we're gonna get to that soon. I'll show you later. Okay, this one is the reverberation chamber. It's in the Kari Building, other side of the BCIT, which is a concrete building. We can change the roof with the different green roofs on it, and then measure the outside to inside or inside to outside noise transmission. And these are different diffusers and different type of green roof inside we put. We can measure the absorption and other acoustical parameters for the different type of materials. This is our computer lab, actually in the NE3 building, which you can see the students working there. Be using a couple of softwares like WinMLS, Samurai, Odeon. These are the softwares that most of the acoustical consultant are now using them, so our student can get familiar with them and hands-on with it, ready to work with. Energy modeling. Good.
Thank you. Hello, everyone. So I'm going to talk about the Building Energy Modeling Certificate. It's a graduate certificate in Building Energy Modeling. But first, I want to give you a little bit of background about the certificate. Why Building Energy Modeling, and why a certificate as part of this Building Science graduate program. So Building Science has different aspects of performance. You have acoustic performance, you have indoor quality, you have thermal comfort, and of course energy. So energy is very kind of key aspect of building performance. Of course, in our program, in the Building Science graduate program, we cover all the different aspects. But energy modeling is key, as you can imagine why. I mean, you all know about the resource depletion and all the amount of resources that buildings use to produce energy, and we know about climate change, global warming, all these things. So energy is a primary focus for governments. And so we have the certificate. That's why we need a special training in energy performance. So that's why energy is important. Again, it's an aspect of building science. And the other part is why modeling. Modeling, what is modeling? So modeling is you can say is a decision-making approach. It's not really a tool. Some people see it as a tool, like using a software. So it's not using a software, it's more like an approach. It's more like an integrated approach to for decision making, to support decision making. So we need that kind of tools now, especially now with the new step code. We have the step code that I guess most of you know about the province's new step code that was released last year. 2017 was enacted. So the step code needs it has as a requirement. Building energy modeling is required to verify performance, basically performance targets, meeting the code. So building energy modeling is now a requirement. So the program, the Building Energy Modeling certificate, was initiated 2 years ago. But I think now this time we have more and more interest because of the new step code in British Columbia. So also it's an integral part of our certificate, and then right now it's becoming more and more relevant. So you can see energy modeling as so what is energy modeling? It's creating virtual models of buildings, basically, to characterize energy flows in the building. Everything is energy. We are just right now emitting energy. Energy is going through, flowing through the cracks in the doors, through the mechanical system. So energy is everywhere. So basically energy modeling helps us to characterize the movement of energy in buildings, and then the consequences of that, basically. So this is a very powerful tool. You can see it's a multi-purpose tool. You have a skill. So when you get into this certificate, you get basically the training into the principles and how to apply this multi-purpose approach or tool. And then another important aspect is that building energy modeling is the principles behind energy modeling are building science, building physics principles. So that's why this certificate is part of our program. So anyways, this is the big picture. So I'm going to talk about the certificate itself. It's a 1-year program. It's fast track 1 year, but it can also be taken part-time. We have both because it's aimed at mostly a local, I mean British Columbian and from Canadian people that are interested in working in or current practitioners, in different areas, architecture, mechanicals, and in building related areas that are interested in getting into this, into building energy modeling. So again, like I was mentioning, it's an emerging discipline. It's a decision-making tool to support capital decisions. Again, right now, if we want to integrate renewables in buildings, you can use energy modeling to verify, basically analyze how can you integrate these renewables basically in buildings. Our curriculum is physics-based again, because this is building energy modeling is physics-based, and again, being part of building science graduate program is emphasized on physical principles. And then, of course, once you know the principles, you know how to integrate new technologies. That's the goal. Because again, we are in BCIT and we're an applied institute, so we are not just in the theory. We need to know how to integrate different technologies, especially new technologies that are coming to support renewable systems in buildings. So this is just a list of decisions can be supported by the Building Energy Modeling Certificate. When you do building energy modeling, you are able to support many different decisions, like I said, including renewables, exploring different ventilation systems, different envelope systems, different renewable systems in buildings, how to integrate and how to combine them together. Because building science, as you can know, you can see like an integrator. You can integrate many technologies in buildings. So basically, decision-making tool, decision support tool. That's what energy modeling is about. So in this program, this is the program map, and this program basically gives you the skills. The goal is to give you the skills for you to become competent energy modelers. That's the idea. You have to become competent energy modelers. It has 3 streams. One is the building science stream. The other one is the building energy stream. And the other stream is the management and communications stream. So again, the building science stream, we have 3 courses. Building science 1, ventilation and indoor quality, and mechanical systems and controls. This is the building science principles. And then the building energy stream, we have building energy performance, advanced energy simulation, and measurement and verification, which is a very important course and was created for this certificate because you have to verify once the building is built that you meet the targets that you are kind of predicting. The measurement verification is part of this. I should mention very quickly that the certificate was created because BC Hydro approached BCIT. BC Hydro approached them, BCIT, because they verify building energy models basically from the industry created, and they realized there was a lack of training, and that energy models didn't have what was required to produce very good models. So basically they needed some formal training in building energy modeling. So they approached BCIT, and some of the courses like measurement and verification were created at the request of BC Hydro, as well as the communications courses and the management. Okay, thank you very much. Oh, that's me again. Okay. So now we'll talk about the research, our own research. So I guess all of us will discuss what we do basically for research. So my research is mostly in the indoor environmental quality and indoor environmental systems. So I mentioned to you energy performance is important and is key. Well, I focus more on the indoor environmental aspects of performance. Basically, I want to understand people, how people interact, how people relate to buildings, and how people affect performance, and how to create buildings that are more responsive to people's needs. That's kind of my main area of research. And I focus on thermal comfort and indoor quality performance, and how to deliver this through building systems. So basically, my research, what I do is I do modeling, lots of modeling, but again, most into indoor environmental modeling. I do a lot of field work, like monitoring buildings, monitoring offices, monitoring houses, and then we do surveys too. We conduct surveys, online surveys on people. So to know how people are feeling in buildings, how basically to monitor how satisfied are people in buildings. So that's a lot of what we do. And then we have laboratory here. We're building a laboratory. It's what's called indoor environmental simulator to simulate indoor environments. And we're going to put people inside and then working and then responding to questionnaires and under different climate conditions. So that's the idea. That's coming. I think that's
Thank you, Rodrigo. So right now we are basically talking about our research interest, and my research interest is actually have 4 research interests. The first one is innovative materials. So I'm interested in learning or doing some research on materials, and the integration of these envelopes, materials, and making to the envelope and their performance in both from the hydrothermal and energy performance perspective. And from the building envelope, then to the whole building performance, looking at the energy performance, and not to the extent of indoor air quality, but from the thermal comfort perspective. And then lastly, the integration of the new technology to the building envelope. So the way my research interests is integrated. First, I will do a research on materials, for example, and then I will be looking at, okay, from now I understand the materials response from its thermal and moisture perspective. So we will be looking at materials from meeting the coarse layer, for example, the vapor transmission property of materials, or the R value or thermal performance of the materials. And then, but when we integrate them as an envelope, the whole system may perform differently. So once we characterize the materials, we assemble as a system, and then we will be test them in test facilities that Bo discussed. And then the whole system the envelope system could be integrated into the whole building, as a whole building. And again, using the whole building performance research laboratories that Bo mentioned. So we'll have 2 buildings with all the envelopes and indoor occupant simulator. So we can simulate people activity in terms of their CO2 productions or moisture and temperature, heat generations, and then we can see how the building envelope respond to from the moisture perspective as well as from the energy use of that building. And finally, we want to understand its long-term performance. So we can do all this kind of testing for a short period of time, for a year time. But how does this building perform in 5 years or 10 years? So we have to do some kind of risk assessment, or its probability distribution of its performance in a long-term basis. So this is the cycle of activities that I do from, so my research starts from the materials to the whole building integration, looking at from thermal and energy, from hydrothermal and energy perspectives. So I have basically 2 major activities, lab and field experiment. So there is a lab and field, and then computer models. So I use the lab and the field to develop the material characterizations or for model validations. For the model validation, of course, we need to have the climate as well. And then the computer model will also help us to design the experiment. So with these full integrations, so we can do experiment data will be used for validation of the computer model, and the computer model will be used to assess its performance in a different climate or in different operating scenarios. And also computer models could be used for risk assessment of these systems. So these are my activities or my research interest and areas. I think Maureen. On Maureen's behalf.
Yeah, Maureen's behalf. Actually, Dr. Connolly, as I said, started with working on the green roofs and living walls first, and then shifted more to acoustics, actually architectural acoustics. The reason is the new materials and assemblies are all designed for the better performance against the moisture, heat, and energy, but it's never actually evaluated for the acoustical properties. It never tested. Most of the new assemblies never tested for the acoustical. And as you know, the mass, for example, is one of the more important things for sound transmission and against the noise. But when you're using the lighter materials and lighter assemblies as exterior walls, then acoustic would be a problem, the noise would be a problem. So one of the main aspect of the research now in the center is we focused on the architectural acoustic, on the transmission loss and acoustic properties. And one of the biggest, actually, the project we had with the BC Housing last year is to test like 60 different type of the new assemblies, exterior wall assemblies, just an acoustical purpose. In these pictures you can see our graduate students, actually these are all graduated, working on the, this is actually Rosa's work on the laneway housing. It's a big project for this NASC. And the other project is noise propagation on the green roofs to see what's the green roofs effects comparing to the normal roofs, the regular roofs. Yeah, this kind of living walls, actually, this is another idea to use them in the office spaces or maybe in the residential use for the sound absorption. And one of our projects is to find out the effect of this kind of living walls inside or maybe outside as well. The other project is the air quality. It was a project actually co-supervised with the UBC for one of our students in the lab. This one, as you can see, it was me when I was a student here, working on the sound transmission. We have assembly here. So we changed, this project was for the effect of the gaps on the exterior walls on acoustics, because the new actually rain screen walls there is a gap between for the air ventilation, and so the exterior part, other side of the gap actually is not working as a sound barrier. So this was for the effect of to evaluate the effect of those gaps. The other project we have in the green roof to see the relationship actually to effect of the photovoltaic panel. So on the green roofs, is it different if you put them on the green roofs or putting on the normal roofs? And we have actually very lots of equipment to measure everything actually over there. It's on the roof. And it's well.
Okay. I guess I need to introduce myself again. My name is Bo, being working in industry for many years, so I do have a strong industrial background. So currently I'm taking the Master of Engineering students only, and my research topics are, since I've been working in industry for many years, was a mechanical HVAC system consulting engineer, and also the building energy performance analyst for many years. So my top research interests are mainly focused on the building performance, energy performance analysis. So if you look at this topic, you probably can guess my research is mainly a simulation-based research. So I'm going to use lots of the different variety of software being mentioned above, such as Transys, Design Builders, and some other software. Simulink, sometimes I'll use that to do additional coding for me to conduct or carry out a building performance simulation analysis. So basically, the building performance analysis includes I'm interested in knowing for a particular type of a building and the particular operating schedules, how much energy is going to be used, not only from the used by lighting, but also used by mechanical systems, heating, cooling, dehumidification systems, and miscellaneous. Second of all is because when I'm doing that, and there's a very natural lead to another analysis, which is the impacts of different types of the mechanical systems control strategies on the building performance. We all know that Rodrigo probably mentioned that renewable energy systems and some other system like this building maybe here is, I don't know, VAV systems, and different building might have different design of mechanical systems, lighting systems, some other miscellaneous load, I would say, building envelope system. They are not discrete. So basically, they all interact with each other. So one of my research interests, I would like to find out how the building performance will be affected by using different mechanical systems. Can I find a most efficient one, or different mechanical systems might have the different performance characteristics under different operating conditions. So they are all different. So I would like to do more research on that. And the other thing is, in a modern building does have lots of waste energy. So basically, you exhaust air to outside. The air in the summertime is cold, dry, relatively, compared to outdoor condition. In the wintertime, when you exhaust air to outside, it is warm and relatively wet, whatever, the air with going outside the building. So technically speaking, you're creating waste. So how do I harvest those waste? And but however, we all know the heat recovery unit and the HRV unit or whatever, they'll be widely used in the building, but when they coupled with different mechanical systems, whether or not the applicability of a particular type of heat recovery or energy recovery systems would be affected or impact negatively or positively. So this currently of the interest to me. So basically, the research funding is application is under process. So hopefully, in the future, some of you will have the chance to work. We can work together on those research topics that are being mentioned here. So, okay, thank you. Sorry.
Hello everyone, my name is Ali Wasayi. I'm a Master of Applied Science student on the supervision of Dr. Fitsam Tariku. Quickly, I'm gonna go over my research thesis just to give you an idea about research study at BCIT. Also, afterwards, I will talk about the student club we have at BCIT Building Science program. So my thesis is analysis of alternative building envelope designs to improve the thermal performance of concrete buildings. Buildings consume a significant amount of energy for cooling and heating. So about 2/3 of commercial and half of residential energy use of buildings are used for for a space thermal load. Transmission heat loss through building envelope components constitute a major portion of the space thermal load. In complex 3D building envelope details, highly conductive structural material and poor thermal insulation create a structural thermal bridging, which has negative impact on moisture condensation, thermal comfort, and mold growing building envelope. So as you see in these three pictures, you can the lighter colors actually they're taken with the thermal cameras, and in the lighter color shows where the building has more heat loss. So mostly at the multi-dimensional envelope details, you see they have more heat loss compared to the rest of the building. So the outcome of my project will help provide solution by designing and developing high thermal performance envelope systems. to reduce the impact of thermal breach, and also help designer to exceed local and energy codes actually, as well as other standards such as ASHRAE and LEED. Regarding the student club that we have at BCIT, which is called BSSC, it's the abbreviation of Building Science Student Club, is an organization started and run by students for students. And our goal in the club is to help in creating a community for the building science graduate students, and also to facilitate support when needed. The BSSC is also an organization which communicates with other universities' graduate student societies about building science from a student's perspective. The club creates a work and social environment between the students, faculty, and staff in the building science engineer department. And also we have monthly events including academic seminars, site visit, and social and student faculty events. The picture that you see right now was taken about 2 years ago. It was for a Christmas party, I believe, that we had in the lab, in the material lab at building science department. So we do have a weblog for building science student club. Also, we have a Facebook page as well. So you can have a look at it, and you'll find more information about the club on the website, and you will see my contact number and also a couple of students there. So if you have any question, you can just give us a call or email us. And I'll leave the rest to Elaine.
Okay, hello everyone. I'm Ellen Scobie. I'm the assistant for the Building Science Graduate Program. I probably emailed, I know at least with some of you here, and online possibly. So I am the point of contact if you have any questions regarding admissions or the program in general. I'm going to go over the most common questions that students have. The full requirements are, of course, on the website. So this year we're doing something different. There's actually 3 deadlines. The first one is coming up March 31st, and everyone whose application is in and complete will have their application reviewed. If you're chosen for admission, you will be notified of your acceptance. If the department isn't sure if you will be accepted or not, you will also be notified, and your application will be moved to the next deadline, which is May 31st. And at that time, a decision will be made. So you will know one way or the other by the end of March 31st or May 31st. The final round is mostly for domestic students. International students can apply, but you must already have a study visa. And the program might actually be full by May 31st, so it's just sort of an extra period of time. So I would encourage you to get your applications in as soon as possible. Once you've passed the March 31st deadline, there's no real pressing need to get your application in, but the sooner you can, the better, because they do get reviewed, but no decision will actually be made until the following deadline. So the application process is all online. You'll see it at our website, bcit.ca, Building Science. The GPA is an important part of your application, and it will be calculated on the last 2 years of full-time study. Now, if you have an application from an international institution, you will need to submit your ISIS report, and the calculation from your GPA will be made from that. Is there anyone here who I know one has studies outside of Canada. Yeah, okay. So you will need to go through ISIS, and they can take 6 to 8 weeks, so it is important to do that.
3 weeks.
3 weeks?
Yeah.
You're lucky, that's great. Glad to hear. So minimum 70%. Regarding a low GPA, we do give students the opportunity to try to raise the GPA by repeating courses that low mark was achieved in. We do ask that you repeat the same course that you got a low mark in. So you'll need to do a little bit of homework to find a similar course to repeat. It doesn't have to be at your original institution, obviously, but at a post-secondary institution, including an online. And if that is something that you need to do, please contact the department with the course that you are proposing to replace the low grade with. And we will verify that the course meets the department's requirements. So the GPA calculation is a weighted GPA. For anyone who has questions, that's how you calculate it, taking multiplying your course credit by the grade to get the grade point, and dividing the total by the total number of credits. When calculating your GPA, you can remove the F grade if you had any F grades to help raise the GPA. Only include the repeated course. Regarding the math requirements, students with engineering background will most likely already have these courses. You require post-secondary level linear algebra and differential equations. Typically, students with an architectural background will not have these math courses as part of their undergraduate studies, so you will need to take these prior to meeting their entry requirements. I include the website there for the BC Transfer Guide. It's a very useful website that, for example, you could plug in UBC Math 221, and it'll give you equivalent courses all over BC at post-secondary. So they'll tell you if there's an equivalent course at Capilano or Langara or somewhere else that might suit you better or might be available in the term that you need it. Pre-university math is not considered adequate for entry requirements. It must be post-secondary. And I touched on the ISIS. There's the website if you need it. And again, the GPA will be calculated from the marks on the ISIS report, not on your original transcript. So qualifying student is a designation that we have for Masters of Applied Science students. If you've been accepted by a supervisor, but you still have some entry requirements to meet, for example, the supervisor will save a seat for you in their research program, so that basically as soon as you meet the requirements, you can join the program in the following year. Note that it's not an official student status. By being a qualifying student, it's basically an agreement between the Building Science Department and you. You cannot apply for a study visa as a qualifying student. Limited funds are available to Masters of Engineering students directly from their supervisor. Typically, more research funding is available directly from the supervisor. Depends on the supervisor and what funds they have. So if you are looking for funding, your best route would be to contact the supervisor and let them know of your need. Fitza mentioned the NSERC, and I've included here the website down at the bottom, the Canada Graduate Scholarships Master Program. You're welcome to apply for funding through that program. There also are some other funding available through industry, and the BC Building Envelope Council also has financial award. We also offer the opportunity for students who don't want to apply to the whole program or don't have time to take the whole degree to take no more than 2 courses for professional development. If this is your case, you do need to meet the entry requirements of the program, but you don't need to officially apply. All you need to do is send your resume and your transcript with a request for the course you'd like to take to buildingscience@bcit.ca, and pending room in the course, because priority will go for students in the program, you are welcome to join. There's my contact information. It's the same that's on the website, so feel free to contact me with any questions. I'm just going to leave some additional resources here. The Building Science Center of Excellence really has a wealth of information about building science and more information about Fitzum Tariku and his research team, as well as a huge list of publications that have been published by faculty and the research topics of previous students. So looking into what students have done in the past can give you a really good idea of what direction you might want to take or the kind of in-depth research that does happen. The other website, Building Science Department, there is also some good information about building science as a field. And the student club also updates with their ongoing activities, and then the Acoustics lab that Omid told us about. There's also a website where you can learn specifically about their projects. So I'm going to open it up to questions if anybody has the specifics. I know there are a few people that came in late, so I want to mention too that I have a range of materials here. There's pamphlets on both the Masters of Engineering, the Masters of Applied Science, and the Graduate Certificate, as well as on some of the research facilities. So you're welcome to take those with you. And just wondering, were there any questions online? No, nothing came in online. Okay.
So if you have any questions?
I have, my degree is first is associate degree and then engineering degree. I have to evaluate both or just at the last 2 years?
Associate degree and, sorry,
and then bachelor degree.
We will be considering your bachelor degree, the last 3 years of your bachelor degree. Yeah.
Vincent, maybe could you repeat the question so that people online can hear?
Okay.
Thank you.
Right. So you have 2 degrees. One is advanced degree, and an associate degree, and then the other one is bachelor degree. And which, if you have to have evaluation of both degrees.
Yes, sir. Today I'm going to send my document for evaluation. They say you have to pay 2 times for the associate degree and bachelor degree. As for your program, they want both or just one.
Yeah.
I just want to know just that the certificate I send you, because it's just for 2 years.
Right.
The first 2 years was associate degree.
Yeah, so if you have associate degree and a bachelor degree, you need only to have evaluation of your bachelor degree.
Bachelor.
And we will be considering the last 2 years of your grades for admission.
However,
Just
curious about that, because you said 2 years as associate degree and also another 2 years as a bachelor degree. So in total it's 4 years, so 2 plus 2. So your math course might be taken in the first 2 years. So we still need to see those 2 math courses you've taken.
My equation I passed in the bachelor degree.
Oh, say, okay. Yeah, just make sure. Yeah, if you know any of the requirement which might be you finish that or complete the course, during the first 2 years, and we need to see that, and it got to be the post-secondary
Oh, okay, I will check.
study. Yes. Okay.
It seems like a simple question. We've got 3 people answering it. Because the other thing is, you should submit your transcript to us as well. We will need to see the associate transcript, but you don't need to get the ISIS report and pay for that.
Oh,
Okay, thank you.
Okay, any other questions?
What is the extent of research that you do aside from, because I know that the mandate of BCIT is primarily education and teaching, so aside from that, what is the extent of research, applied research that you do here?
The project that we will be working. Okay, sorry. Okay, so your question is what kind of research we do, given that BCIT is more course or practical kind of education institute. We combine both. So we combine the practical aspects and the research, fundamental to applied research aspect. So in terms of our research activity, it will be comparable to any other post-secondary institutions. In fact, we compete for funding with other institutes. So our research activity not only just doing the research, but we has to be peer-reviewed research, higher level of detailed research. So, but the projects that we'll be taking are most of them are industry applied. So we try to look at industry applied projects, but the detail of research has to be at higher standard as any other post-secondary scientific research.
Do any of the programs include any type of LEED certification?
We don't. Okay, that's the program leads to LEED certification. We don't focus on program delivered LEED certification, but what you'll be learning from our program will be making it very much easy for you to have LEED certification, given that we teach from the fundamental applied to just highly like real high-rise building, for example, energy modeling and stuff like that, and analysis from different aspects. I know in one of our course we also touch up different requirements like ASHRAE requirement, LEED requirement, and so on. So we don't specifically look at LEED, but we know it's important, and yeah. Yep.
In LEED, it is one I think not, I wouldn't say most important, but a very important portion, which is the EA credits, environment and atmosphere. So that is highly related to energy modeling. Of course, as a LEED consultant, they don't need to know specific about how to do the modeling, but our program does provide a very sound sufficient training in terms of how to do any building performance. So it's not only how to use the software, but also the principles behind the building science. So it would help the student if in the future they want to go for a LEED exam, or they want to go for, now I think it's very popular as a passive house. So essentially, if they want to go for a passive house examination, in general, it will be very easy for them to. Actually, we do have a couple of graduates already passed the passive house, and I asked them how was it, and they say, relatively speaking, it is very easy for them in terms of the envelope portion, and I think pretty much the same as LEED, and yeah, okay, no problem.
Any more questions? Yeah, so as Ellen said, if you have any questions, you can send to her. And if it's related to supervisor or research areas, you can contact us. You can find our contacts in our website, and we'll be happy to discuss with you opportunities. there's no questions, then
No questions online, I think.
all right. Okay, thank you very much for coming.